MathKlik.
Mabuhay! What are sequences? How can you write a rule for the nth term of a sequence? How can we generate patterns? In this lesson, we will discuss how to define and illustrate sequences. In general, a sequence is a list of numbers in a specific order. Each number in a sequence is called a term. In the sequence 2, 4, 6, 8, and 10, the first term is 2, the second term is 4, the third term is 6, the fourth term is 8, and the last term is 10. There are 5 terms in the sequence. Since the number of terms are determined, the sequence can be described as finite sequence. Not all sequences have a first term or a last term or both. In this sequence, the first term 1 is specified, but it has no last term. Take note of the ellipsis or the 3 dots. It indicates that the sequence has no end and therefore the terms cannot be counted. This sequence is an example of infinite sequence. The presence of ellipses in a sequence does not mean infinity all the time. Look at this next sequence. It has a first term 9 and a last term 108. The ellipsis is used to abbreviate the listing. If all the terms are listed, there would be 11 terms in all. Thus, this sequence is a finite sequence. This next sequence started with an ellipsis. This indicates that it has no first term, but the last term 2 is specified. Thus, the number of terms cannot be counted, which means that this sequence is an infinite sequence. Suppose you are asked to find the next 2 terms of the sequence 12, 19, 26, 33, 40, and so on. Let's look for a pattern using the given terms of the sequence. Notice that the second term 19 is 7 more than the first term 12. The third term 26 is 7 more than the second term 19. The fourth term 33 is 7 more than the third term 26. And the fifth term 40 is also 7 more than the fourth term 33. The pattern is clear. To find the succeeding term, simply add 7 to the last term. Hence, the sixth term is 47 and the seventh term is 52. Consider the next problem. Find the next 2 terms of the sequence 32, 16, 8, 4, 2, and so on. Again, let's look for a pattern using the given terms of the sequence. Notice that the second term 16 is 1/2 the first term 32. The third term 8 is 1/2 the second term 16. The fourth term 4 is 1/2 the third term 8. And the fifth term 2 is 1/2 the fourth term 4. The pattern is simply dividing the last term by 2 to find the next term. Hence, the sixth term is 1 and the seventh term is 1/2. Here is another problem. Find the next 2 terms of the sequence 1, 4, 9, 16, and so on. Again, we look for a pattern using the given terms of the sequence. If we use the same line of thinking used in the first 2 examples, no number can be added nor multiplied by the last term to find the next term. So, we look for a different pattern to write the next 2 terms. Notice that all the terms in the sequence are square numbers, meaning These numbers are results of multiplying a number by itself. The first term 1 is the square of 1. The second term 4 is the square of 2. The third term 9 is the square of 3. And the fourth term 16 is the square of 4. The pattern is now clear. Simply square the cardinal number corresponding to the next term. Hence, the fifth term is 25 and the sixth term is 36. A sequence can be expressed in a recursive form. A sequence is said to be in recursive form if the first term and a recursive formula are given. A recursive formula is an expression used to determine the nth term of the sequence by using the term that precedes that term. Let's transform the sequence 2, 4, 6, 8, 10, and so on to its recursive form. The first term is 2, the second is 4, the third is 6, the fourth is 8, and the fifth is 10. Our objective is to express this sequence in recursive form. Remember, to do this, we need a recursive formula and the first term. Again, the first term is 2. The second term 4 can be expressed in terms of the first term 2 by adding 2. The third term 6 can be expressed in terms of the second term 4 by adding 2. The fourth term 8 can be expressed in terms of the third term 6 by adding 2. And the fifth term 10 can be expressed in terms of the fourth term 8 by adding 2. The pattern is clear. Simply add 2 to the last term to find the next term. Let's write this in its formula. A sub n is equal to a sub n minus 1 plus 2. The given sequence is now expressed in recursive form. We can now use the recursive formula to find the sixth term. Since the fifth term is 10, the sixth term is 10 plus 2 or 12. Recursive form is not a flexible expression for a sequence. If we want to know, say, 10th or 25th term in a sequence, and we are only given the first few terms, then we still need to calculate the 9th or the 24th term respectively to find the 10th or the 25th term. That's tedious. However, there is another form of a sequence that does not rely on the term that precedes the unknown term. This form of a sequence is known as the explicit form. This sequence does not need a preceding term to find the next term. A sequence is said to be in explicit form if a corresponding formula designates the nth term of the sequence. Again, let's use the sequence 2, 4, 6, 8, 10, and so on to explain this. The first term is 2, the second is 4, the third is 6, the fourth is 8, and the fifth is 10. Our objective is to find explicit formula in terms of n, where n refers to the position of the term. Remember, this formula may be used to find any unknown term of the sequence. Now let's look for a pattern. The first term 2 can be expressed in terms of its position as 2 times 1. 1 here refers to position 1. The second term 4 can be expressed in terms of its position as 2 times 2. The third term 6 can be expressed in terms of its position as 2 times 3. The fourth term 8 can be expressed in terms of its position as 2 times 4. And the fifth term 10 can be expressed in terms of its position as 2 times 5. The pattern is now clear. Simply multiply the cardinal number by 2 to find the nth term. Now, let's write this in a formula. A sub n is equal to 2n. The given sequence is now expressed in explicit form. We can now use the explicit formula to find the 10th and the 25th terms. If n is 10, the 10th term is 2 times 10 or 20. And if n is 25, the 25th term is 2 times 25 or 50. Now try this. Find the next three terms of the sequence negative 37, negative 24, negative 11, 2, 15, and so on. Here are the answers. For more matitinik tips, just click MathKlik. And please, don't forget to subscribe and click the notification bell for our next video lesson. See ya!